there's a lot of things to be excited about these days. There are robots that are building our cars. There are robots that drive our cars for us. There are robots helping us with deliveries in the Amazon warehouses, and all these really cool advances right now in robotics. And there's a lot of things to feel stoked about. At the same time, there seems to still be a bit of a gap, right? Like, we look at robots in a factory that is like doing really cool, interesting things, but like that's still different from this vision and dream of autonomy. So I wanted to do a quick presentation because robotics is so visual. Like, I can talk to you about robots, but wouldn't it be more fun to actually watch robots do really cool things? So I'm just gonna do a really quick talk, just almost like a literature review of what I think is like the coolest research work being done in robotics. And then tie it back into, well, how can we take really cutting edge work and actually apply them to real-world problems, like some of the things that we're working here at Medra. So I want to talk about autonomy and the future of AI-powered robotics. And the thing I think you should know about me more than any of my credentials, or what my thesis for my PhD was, is that I love robots. I love robotics. I grew up watching and reading sci-fi. I love WALL-E, and I'm really, really excited to be nerding out with you all about robotics today. So I hope you guys are excited too. And I mean, as a total nerd and geek about robots, like, there's a lot of things to be excited about these days, right? Like, there are robots that are building our cars. There are robots that drive our cars for us. There are robots helping us with deliveries in the Amazon warehouses, and also robots that will actually make those deliveries to our houses. So there are all these really cool advances right now in robotics, and there's a lot of things to feel stoked about. But at the same time, there seems to still be a bit of a gap, right? Like, we look at robots in a factory that is like doing really cool, interesting things, but like that's still different from this vision and dream of autonomy, right? Like a WALL-E who can remember to put up his tracks when he goes at home so it doesn't dirty his trailer, and then he's like wants to watch his favorite movie on his little iPod. And that's really like the dream you and I have about robotics, not just, robots that can build our cars. So like, where's that gap? And so I want to talk about a difference between what I see as like automation and what I see as autonomy. So automation is really specialized robots, and then you have engineers who like program it and spend hours and hours and hours of getting the robot to do exactly what you want to do, and then the robots will do very specialized tasks. But what we think about autonomy is, what if we can have a general purpose robot? Maybe that's a humanoid robot, maybe that's a robotic arm that has human-like dexterity, and then it can do anything, right? It can do general purpose things and be autonomous. So what's that missing gap there, right? And I think the answer is AI. And I want to talk about what are the components to AI that actually will make autonomy happen. So components to AI enable general purpose objects. Is it foundation models? No, I'm not going to talk about foundation models today. Foundation models could be a way we can reach the autonomy, but I actually want to talk about components. And those components could be achieved through foundation models, but foundation models might not be the only way we can achieve it. So I want to talk about three things, the three components that I think is necessary to reach autonomy. One is feedback loops, or in academia we call it perception action loop. Learning from experts, and lastly, understanding of language. So I'm going to try to go through this really fast, and again, this is going to be kind of a quick literature review of what I see are the coolest things that are happening that are able to exemplify these three components. So okay, feedback loop. Here is a robot that can actually see things. There's a camera pointing at the whiteboard, and as you draw things, it wipes the whiteboard, right? There's feedback happening. It's perceiving, and then it's acting, right? So you want robots that actually can perceive the world and act on it. That's what feedback loop is. Now, feedback loop can be really low level. In this case, this robot is just trying to track where this object is, so it's just following it as it goes. Or it could be something more high level, like a reward. So you give it a reward, and there's some way to predict a reward, and people who have done robotics research might recognize this as like a very simplified way of explaining reinforcement learning. And so you give the robot a reward every time it does the task, right? And so that's how we train this robot to wipe the whiteboard. Whenever it wiped the whiteboard clean, we gave it a reward. So it just learned by getting the feedback of what's good. Well, the thing with feedback is it can be really difficult to program. So something like this wiping task, we actually trained for like 2 weeks straight in simulation, or what amounts to real world 2 weeks, and just for something wiping, and then we then transferred it to the real robot. And so that seems like a long time, anytime you want to do a new task, to have to train it and create a simulation model. So what if you could, instead of having to figure out what the right reward is and program it, you could just teach the robot what to do, just like how we learn a lot of our new skills. So learning from demonstration. So this is some pretty cool work out of Stanford, where they built a system to demonstrate to the robot how to do something. It's just you're controlling a robot that then controls another set of robots. And then the robots are able to learn how to do these tasks. And this is just pure imitation learning or supervised learning. And the robot's able to learn some pretty complex tasks. And again, without any having to program any very specialized rewards. It's just pure demonstration, and it's able to learn how to do these things. And it doesn't have to be from really complex systems where you have to build this really cool robotic setup. You could potentially learn demonstration from videos itself. And there are also some really cool works where you can use special gloves, or you can have special grippers that can do these demonstrations. So if we could just teach a robot, kind of similar to how I learn things. Like when I want to learn how to change a wheel on my car, I just watch a YouTube video. That would be a great way to teach a robot how to do a new task. Now, there are limits to this kind of demonstration learning from experts, imitation learning, which is that, you want to teach a robot a task, but maybe if you want to teach a robot how to cook, it's like, well, first you want to cook an egg, then you want to cook some rice, and then you want to serve it together. But sometimes you're like, I just want my egg by itself. You don't want to demonstrate this long task of cooking an egg and cooking rice. You kind of want to have components separated and then stream them together. So you need some way of planning how to string these different skills that you're learning together. And that's where language is actually a great way for robots and for us to plan and learn. And there's been some really exciting work. This is out of Google DeepMind, where you can actually give language instructions and the robot can just be able to plan out how to do certain tasks. That'd be great to use that as a way to do planning. And part of that could be LLMs that is able to understand the language. But it doesn't have to be. You could also think about planning from symbolic language, which is what this work is trying to do. There's no LLMs here. This is just symbolic language, task and motion planning, and it's able to do some really complex things. No LLMs involved, and plan out these tasks. So I want to then, again, say what these three components are. We want feedback loops. We want then a way to learn from experts. And lastly, we want a way to plan things by understanding language. So these are the three things that allow us to achieve autonomy. So thanks, everyone. And yeah. You take a seat? Yes. I'll take this seat. You want some water? No, I'm good.
Okay, Michelle, thank you so much for walking us through that. That was our first Thursday Nights in AI talk.
Oh,
so
great.
Yeah, presentation and everything. I love it. Super excited to chat with you and hear more about both your research and then also the company. And I think I would love to start off with, you just walked us through all of this incredible research, which you yourself contributed to.
Yes. Not all of it, like most of this work was like from colleagues and from other people in academia.
Yeah. So how did you decide to, one, build something, become a founder, and then two, how did you choose wet lab automation as the vertical to apply all of your robotics expertise to?
Yeah, so my work in academia was not at all about biology and wet labs. It was on general purpose robotics manipulation, and a lot of my work was more on like manufacturing related work, or some of it was on like kitchen automation. And I had considered either joining or co-founding companies in a warehouse automation space, manufacturing space, food manufacturing, like making your Chipotle bowls, or even agriculture, like picking strawberries in greenhouses. So there's a lot of use to really general purpose robotics. The reason why I got excited about biology, partly honestly, is because of COVID. I was finishing up my PhD during COVID, and I got really OCD about reading anything about COVID vaccines, like mRNA, spike proteins, and then that led me to reading about stem cells. And like the more I read about it, the more I got really excited about a lot of the breakthroughs happening in biology. But at the same time, like, okay, we've been able to take a human skin cell and turn it into like an eye cell by turning into a stem cell, like for more than 10 years now. Like, why is that not a drug? Like, why am I not like seeing people who are blind, like just take their skin cell and turn that into like new eye cells, right? And I realized the big bottleneck is just, you can show something work in a test tube, you can show something work in a lab, but that doesn't translate to an actual product because of how difficult it is to run these experiments and gather all this data. And so biology is extremely data limited, and that data is very labor limited. And that's, robotics is great for that. And so I got really excited about biology because I think the impact you can make if you can scale biology and automate biology, it's probably far greater than any other fields that I can work on. So I want to spend my life doing really meaningful things, so I want to work on automating biology.
What has that journey been like to go from researcher and academic to founder?
Yeah, there are definitely some similarities, but there are also a lot of things that are very, very different. In academia, what you care about is novelty. So you need to look at what state-of-the-art research is, and you just need to make a little bit contribution to it. And as long as it's novel, and you can show that's novel, you'll get it published. But in industry, people don't care about novelty. You can be like the 10th company, 20th company doing something, but if you really solve what the pain points of your customers, like, then doesn't matter if you're late to the game, you will still be able to make a big impact. So kind of shifting my mindset from thinking about novelty to what is the biggest pain point? How can I actually make an impact? How can I bring value? That's been a really great learning journey for me, and also makes it feel like I'm doing something really meaningful.
We're seeing a ton of folks, I think in this audience we have some researchers, and just generally, especially with this AI boom, we're seeing a ton of researchers go into industry, joining OpenAI or building a company of their own. To researchers in this audience or watching live who are thinking about that, do I continue down the academic track or switch over? Yeah. What are the things that you would encourage them to think about when making that decision?
I think it really, in the end, depends on what you're passionate about. I don't think, actually, there's anything wrong with wanting to work on something that's novel. And I think there's tremendous impact you can make in society by doing fundamental research. For me, though, I just feel drawn to this idea that what I can build can affect millions of people's lives. Like that is what drives me, rather than like publishing a paper that maybe only thousands of people read. And so, but for some people, like that idea of working on something novel, being part of a tight-knit research community is really exciting. So in the end, I think it's most important to really know yourself and like what really drives you and motivates you. And if you're working on something that motivates you and drives you, you can do your best work there.
Speaking of novelty and research, like where do you see robotics research going over the next 1 year, 2 years, 5 years, 10 years? Like what companies are possible today and what companies will start to be possible in the next few years?
Yeah, so robotics has recently kind of crossed the threshold that self-driving cars and also self-driving cars crossed maybe 10 years ago, and then now like natural language NLP research crossed like maybe 2 years ago, which is that you're now probably going to see a lot of difficulties in making, or we're starting to see robotics being dominated by very data-intensive models, which means that it's harder to do that kind of research in academia. So, you know, self-driving car used to only be in academia, but then I would say about 10 years ago, you started seeing most people who wanted to do that kind of work join industry. And so I think we're starting to see that shift too in robotics, where not only are people choosing to join industry, a lot of professors are leaving academia or taking leaves to start companies because you're just starting to realize, like, I think people are starting to realize that like there's a lot more resources in industry. But with that said, I think, again, like there's still a lot of value to be doing fundamental research in academia. And in terms of what companies are possible in the next 5, 10 years, I think as more of these foundation models are coming out in like vision, in vision language, in terms of vision language models, robotics companies can start using them, and so can make a lot more progress a lot faster, which just means that what could take like maybe a team of 10, maybe 3 years to build, you can actually just use some off-the-shelf models to start pretty quickly. So I think what's exciting is the barrier to entry is definitely lowering.
I'm curious, you mentioned foundation models, you mentioned that in your talk as well, and I think you were kind of like, oh, I think you hinted that there was some action in that area, but that was maybe not the path that you were most excited about. There are a few companies starting out that are thinking about foundation models specifically for robotics. Mm-hmm. I'm curious, what's your take on that movement?
So, as a founder of a robotics company, I'm excited, right? Like, I would love, you know, this promise of saying, you know, downloading a model from Hugging Face and then, you know, fine-tuning it and it just works. I think we are years away from that. So while it's exciting, I don't see it happening anytime soon that I would just be using like a robotics foundation model, you know, pip install it, and then it just working on the robot. What is more likely to happen is you might want to, for your computer vision system, you might want to use a vision foundation model that can maybe segment anything. By using that model, you can now have that as an input to your controller, which is not a foundation model. It's maybe specific to the task you have, but then is able to take the output of the foundation model to more easily do a task. So I see it more likely that we're gonna see a lot of components to robotics that used to be very difficult to build in-house. You can start using off-the-shelf tools for that.
I'm curious, there's been this crazy momentum in AI and LLMs for the past few years. What has that meant for robotics? Like, does it matter to robotics?
Absolutely. I think it definitely matters to robotics. Like I said in my talk, I think the idea, like robotics, the tasks you want robots to accomplish for you the more complex it is, the more kind of planning you would want it to do. And language is one of the best ways that we can do planning and describe plans. And so it's a great medium. It has a lot of semantic knowledge in it. And so being able to use language as an input and also as a way to plan out complex tasks, I think is really exciting.
Okay, then go ahead, Josh.
What's your take on humanoid robotics and robotic form factors? Like, is it all just going to be a bunch of humanoids walking around, or will there be tons of diversity, or something in between? Like, what do you think? What do you see happening there?
So, humanoid as a form factor just makes everything harder. Just getting a humanoid to walk and be balanced can take just tons of work to do. And so it's really a question, like, do we need that form factor? Or is it possible to put like 2 arms on a mobile platform that is able to still go around your building? Maybe you do. Like, maybe if you are in like a disaster zone and you're like on rubble, you might want a humanoid, or maybe you want drones that can fly around. So I think rather than thinking of like one form factor, I'm most excited about how different form factors of robots can actually work together. Like, imagine, again, you're trying to do a task, and some part of it could be done well with a drone, some other parts could be done well with a quadrupedal robot, and then other parts, maybe you do need a humanoid. And imagine like an Avengers team of robots all working together. I think that's going to be what's exciting. So then the challenge is still on the software side of how you can get these robots to collaborate.
All right, last question, then we'll go into the rapid fire Q&A part.
Great.
Which is, and I know you've been asked this before, it's kind of the question on everyone's mind, which is there going to be a chat GPT moment for robotics?
I hope so. I don't think we're there yet. Someone recently asked me, Michelle, like, what is like the GPT-3 moment for robotics? Is it now? Because everyone's talking about foundation models for robotics. And I would say that right now in robotics manipulation, especially like a robot arm being able to manipulate things, we're probably around where self-driving car was maybe 8 years ago. So about 8 to 10 years ago, self-driving cars started. There's a lot of excitement around using computer vision models to be able to accelerate self-driving. And it did hugely accelerate self-driving, but it's still, like right now, like 8 to 10 years forward, you're still seeing kind of some struggles to really generalize and deploy widely, but we're making still tremendous progress there. So I would say, like right now with the excitement of foundation models robotics, we're right there where people are seeing great progress in other fields. They want to take that technology and bring it to robotics manipulation. And it's going to make huge progress, but there's still a lot of work to be done. I don't think we quite hit like a GPT-3 moment for robotics.
Awesome. Okay, we're going to do some rapid fire Q&A, and then we'll move to audience Q&A. So please use the QR codes, and we'll go through as many questions as possible. All right, we're going to do some questions about robotics and Medra, but then also just building a company. So let's start with that.
Okay.
Who is one founder or leader that's inspired you on this journey?
One founder and leader. I actually think that I've been really inspired by Kanjun and Josh. They're also right here, so it was really easy to point to them. I was working on a different idea the first 6 months of starting a company, and I realized in 6 months that that idea totally did not work. And I very scared, like texted Josh to see if he would like talk to me, and I like admitted to him, like, I think this idea I'm working on totally does not work. He was incredibly calm and supportive, and it made me realize that, you know, part of being a founder is not necessarily about having the best idea and making always the right decisions, but a lot about just being resilient, being creative, and also staying really calm under pressure. And that's what I've learned a lot from Josh and Kanjun.
Me too.
All
right. Any hot takes you have about robotics? Anything that people just typically get wrong?
What do people get wrong about robotics? OpenAI did not solve robotics when they were able to solve the Rubik's Cube a few years ago. A lot of people have told me, why isn't robotics solved yet? I thought OpenAI already solved robotics, and that is, robotics is not solved yet.
It's not solved yet. You heard it here first. Josh, you want to go with one? Okay. Have you seen anything like weird or interesting, like a weird application of computer vision or robotics?
Weird application. I think the application I'm most excited about is this company AMP Robotics that's using robotics and computer vision to sort trash. So a few years ago, China stopped accepting or increased the purity needed for recycled materials to be sent over to China, and then a lot of recycling plants actually shut down because they could no longer make money. AMP is just using robotics and computer vision to sort trash, which is like, people talk about robotics as, I think, dirty, like doing things that are dirty, dangerous, and then I don't know what the last one is, another D, dumb? I don't know. Yeah, maybe.
That sounds good.
Yeah, that sounds good, right? And that's definitely like a dirty task, and I'm glad, someone's working on that problem.
Yeah.
Open source it for robotics? Does it matter?
Does it exist?
Ross, yay or nay?
I think that the issue, I think like components of robotics should definitely be open sourced. Something with ROS that's really difficult about it is it tries to do everything, and then it forces you to use all the things. Like, it has its own CMake for people who, use C++. It has its own version of CMake. Like, why? CMake works perfectly fine. Why would you want to use CatCanMake? And it forces you to use all of that and forces you to adopt its way of doing robotics. And I think what is a much better way to do open source is, again, like, maybe there's a computer vision model that you want to use, open source it. Maybe there's a vision language model you want to use, open source it. And I think that gives everyone a lot more flexibility.
Best piece of advice you've ever gotten?
Best piece of advice I've ever gotten is, if you're the dumbest person in the room, you get to learn the most.
Worst piece of advice you've ever gotten?
Worst piece of advice I've ever gotten. I wasn't able to make that work, so you're never ever going to be able to make that work.
Nice. Are we entering a hype cycle in robotics?
Probably, yes. Yeah.
What's one thing you're compulsive about?
Compulsive about. I don't think I'm really compulsive about anything. Sometimes when I walk, I like to make A patterns as I walk. So maybe that. Yeah. Just I've always done that when I was a kid.
I love it.
Yeah.
Do you believe in work-life balance?
No.
How many years till AGI?
Oh. You should answer that, Josh. I don't know.
I want to hear the robotics equivalent. Like, what does robotics AGI look like?
Robotics AGI. Yeah, so it would be robots that could actually, you could just tell it what to do. I mean, again, like, I think we all have that vision in our minds. Like, when I showed WALL-E, it's like, everyone's like, yeah, like, we all have seen what that would look like, but
how many years?
we're close.
2 or 3?
We're far, very far. I think maybe I'm very pessimistic, but I think there's some really cool demos right now of what that could look like, but we're at least 10 years away.
Awesome. All right, we're going to go into Q&A. And actually, this is fine. I'll use this. All right. I'm going to call on folks, so please stand up and you'll get a mic to ask your question. So let's start with Catherine Lee. Catherine, stand up if you are here. Right here? All right, let's get our mic.
Oh, I thought you were just going to read the question, but all right.
Sorry.
No problem. So Yes, let me try to remember my question. It got submitted and I didn't see it. But I was just wondering, actually, because you mentioned there's a lot of folks who have transitioned from academia to industry. And so I'm wondering for you, do you feel the advancement of like robotics in general, or even like, autonomous cars has been impacted by this shift? Do you feel like it's been more fruitful that there's been more people moving from like academia to industry, or do you feel like there was more cool things or advancements being done when there were more folks like limiting this to like academia?
I think it's fantastic that more people from academia is moving into industry. Again, like I think academia is a lot more focused on novelty. So sometimes you have works that come out that might be publishable, but might not actually be something that can be turned into a product anytime soon. I know that because I've worked on stuff like that have won awards, but like I just know that this line of work will not be applicable to real world problems. So I think it's really fantastic that more people are thinking about how you can apply these advances to real world problems.
All right, John Manns.
So long question, but I feel like the last 4 or 5 years of robotics has largely been about trying to find really high ACV use cases for robots with good ROI, good unit economics, but really complex deployments in order to justify that ACV. I feel like a lot of the research that you talked about and also that we've seen in foundation models for robotics recently has been about dropping out the floor for really simple implementations of robotics, pick and place, et cetera. How do you reconcile those two things? Like, do you think the answer is because it's now just so easy to build really simple robotic implementations, you see more companies like yours that are full stack and using robotics internally as part of the value prop versus standalone, complex, robots for deployment? Or is there some way to bridge the gap between those two universes?
That's a really great question. So I would say that these more complex robotics projects are currently all built by systems integrators that are doing very custom work. So most factories that are automated, they are just going to these integrators who then will sometimes build specific machines for them to automate like a very specific process. What I see as really exciting is what if we can, and it could take like months, if not years, to kind of set up these systems. What I'm really excited about is like, can we take like a general purpose robot, like a robot arm, and be able to automate anything in a factory? So similar, like in biology, like lab automation has existed for like decades now. But what that has looked like is you buy very specialized machines that then have an API to it. You have to wait for a company to make a machine with the API to it, and then you string them all together to automate it. What's different about what Medra is doing is we can basically use the same form factor and automate almost any instrument in your lab. We don't need an API. You don't need to wait for Thermo Fisher to come up with an automated version of something. And what that means is it is actually more cost effective and it's much easier and faster to automate. And also, thirdly, I think it's going to be more robust. So you're going to be able to do it more cost effectively, faster, and more robust. And that's what generalization will bring.
All right, a few last ones. Tom Ken. Anyone? No? Okay. Robert Chandler.
Thank you. Yeah, I was just wondering, do you think there are any self-driving car companies out there today that are actually going to reach level 4 autonomy at a cost-effective per trip manner?
I am not an expert in self-driving cars, so I first want to say that I don't have like a really great model of exactly what makes it expensive, but I would imagine what makes it expensive is the data collection, the labeling, and also the human interventions needed. So anytime you need a human to intervene, then what's the point of automating? You're just paying someone to do it. And so I think that there probably needs to be some kind of breakthrough that we haven't seen yet in terms of being able to deploy faster into more cities without needing like so much data and data labeling. And then somehow if that breakthrough also leads to more robustness, then you might also be able to get rid of as much human intervention as necessary. But if that breakthrough doesn't happen, then what's going to happen is, again, like you go to a new city, you have to collect a lot of data, and then every time you go to a new city, you have to collect a lot of data. And maybe what could happen is you collect enough data and then you just scale, right? And so there's kind of a shift into generalization, which we've seen in language models. But how much that data is required, I don't know what that would look like yet.
All right, last question, Ivan Nenov.
Hi, Michelle. Thanks for the great talk. What do you see as the most significant limitation of the current language models when applied to robotics, and what research direction could potentially overcome these limitations?
I think what people don't realize when you think about large language models applied to other fields is there's actually a lot of field and problem-specific advantages. So with something like language, if you're asking ChatGPT to compose an email for you, you will check what that email looks like before you send it out. There is inherently a human in the loop, and so there's an expert in the loop. So self-driving, right? Like, you actually want to minimize the human in the loop. You don't want a human to take over because you want to reach pure autonomy, because that's the most cost-effective way of automating driving. And so what's difficult in robotics is you actually want to minimize human in the loop, and you want to minimize any errors possible. You want to be robust, because if it's something like driving, you could be hurting someone. And if it's something like a warehouse, you are losing economic value for your customers if you can't pick the correct thing. And so what's difficult about using current systems is you just can't get to that 99.999 or maybe 6/9 % of robustness that's necessary, because a lot of the fields that we're currently using LLMs in, you don't need that. Right? You actually can get by with 50% accuracy. Like if Copilot writes the wrong thing for you, well, you check it before you say yes. So it's okay if it's wrong, even half the time. But imagine if a robot goes to your house and like half the time it cooks for you, it breaks your plate and wrecks your kitchen. Like, that's absolutely not acceptable. And so how can we actually create tools that can get that robustness is a really big question. And it's not quite about LLMs. It's actually about the fact that the field of robotics, or like the problem of robotics, requires a different level of robustness and confidence that's not necessary in maybe other fields that's purely language-based.
All right, awesome. That was our last question for tonight, though Michelle's going to hang around for a little bit if you want to come and meet her. Michelle, I want to say thank you so much. It's been such a joy to be a part of your journey as an investor, and then also to have you join us here tonight. Thank you for giving us your talk and for answering these great questions. So thank you so much, Michelle, and round of applause for Michelle.
Thank you guys. Thanks for having me.